Good evening here, morning, whatever time you are listening this art. Mike Banda here, and I'm going to explain biostatistics, introductory part to biostatistics. Okay, so biostatistics, we need to understand first what is biostatistics. Biostatistics is split into two. There's the word or the, the component of the word bio, okay, and there's the other component, statistics, okay. And you understand that bio means life, statistics means numbers. So biostatistics is the aspect of you actually using numbers, okay, to be able to come to a conclusion of what the problem is in the study that you are trying to conduct. So biostatistics, on how you carry out that conclusion, you don't just arrive at the conclusion based on what you've seen, like we do in reality, real life, where you just look at something and then you judge using your experiences of life of the past or anything. In biostatistics, we take every study, every observation, every measurement as new. Okay, therefore, biostatistics is systematic, meaning that it comprises of different parts before you come to the conclusion. It comprises of the data, raw data, data collection, and then you gather that data, you now order that data, and then you analyze the data and come to the conclusion. Therefore, biostatistics is the process of systematically collecting data, organizing data, analyzing data, and coming to a conclusion. Okay, and so in biostatistics, the very first thing that we have to start with is variable. What a variable is, and of which we have to understand that the variable, these are simply things that we want to measure or record. The things that are actually going to help us to arrive at the data that we want. So these are simply characteristics or properties of the item or of the place or of people that we want to know. And so variables, these are simply things such as age. Just you mentioning age, that is a variable, that is a characteristic. Okay, you mentioning, for example, blood pressure is a variable, it is a characteristic. Okay, you mentioning in other ways, how would know what a variable is, you have to think of it in this way. You remember in mathematics when you're looking at uh, what were those, a plus I mean x squared plus 2ab plus c, the quadratic equations, they had constant numbers and variables. Variables were letters, isn't it? For example, if we write 2x, x is a variable, 2 is the value or constant. So variable, you can think of anything, words such as age is a word, so it's a variable, it's a characteristic. Blood pressure is a word, it's a variable, it's a characteristic. HIV status or just status, it's a variable, it's a characteristic. So all of those things that are going to help you now when you observe or when you get your details, they're going to lead you to data. Then uh, those data or that data becomes the values or the data. So a variable is simply a characteristic or a property. Like I have mentioned, mnemonically, you can think of a variable from the quadratic equations. All of those letters in that equation were called variables. So a variable, in this case, we're talking about words, anything that you talk about characteristics. Okay, so a variable is any characteristic that can take different values across people, places, or time. So when you pick, for example, blood pressure, you have to test it across people, places, and time. Why you are trying to do this? It is because, remember, in public health you are dealing with the population and not people. So if you just test it to maybe few number of people, your data is going to be limited. So you want to make sure that you actually go beyond people. you go beyond one person. Maybe you test different people of different sexes, people with the same variables such as blood pressure. You test people who are in different areas or different places, so that you come to a conclusion that is going to show you a distribution of what you're trying to measure across the entire population and not individuals. That's why it's important to measure these characteristics of variables across different people, different places. Now, that data that you have, because you are measuring it across different people, you're going to be able to know that maybe the disease is affecting people who are in this particular age group and not people who are in the other age group. So that is going to probe you now to ask a question: why then does this disease affect this other group of people and does not affect the other group of people? By you asking that question, it actually means what you've now turned that variable, it means you've turned that variable into a random variable. Random variable, it's where after you've observed the data or the pattern, you ask why is it so. By asking that, it means it's a random variable. So the random variables, these are variables whose exact values you do not know. Okay, you do not know yet. For example, number of malaria episodes a child has in 1 year. Are you going to know just by asking? No, you have not yet carried out records or interviews or measurements. So that is a random variable. If in other ways, you can think of a random variable as a precursor of data. Like, you haven't yet arrived at the data, but it is what is helping you, what is coming immediately um, before the data. Okay, so apart from that, you now have to, after you ask yourself that question, you have to go on the actual ground to either record or measure. Here we've mentioned record or measure, and if you record something, if you observe something and record what you've observed, that recording becomes your data. If you've measured something, for example blood pressure, using all the instruments and stuff, that thing that you're going to measure, the BP, maybe 120 meter mercury, that measurement becomes your data. So therefore, data is simply the actual or recorded values of variables that you get either by observing or measuring. So the data that you get by observing, that's what we call qualitative data. It is just going to show you how distributed uh, your recordings are across different people. Okay, and when you observe data, when you get data by observing, you are not using any instruments at all. You are only using your naked eyes. For example, how do you do this? You can go maybe at the hospital and you simply sit somewhere and start observing people who come to that hospital. Are they washing hands? Are they putting on face masks? And then you put your data as yes or no. How many are putting on masks? Maybe there are 20. You put that. So what you are recording there is becomes your data through observation, and that kind of data is what we call qualitative data. Okay. Uh-huh. And now when you use instruments to measure what you want to measure, for example BP, temperature, you use instruments. For example, when you want to measure weight, okay, that measurement, you do it by using instruments. You are involved, and then you record the weight. That weight or that height or that blood pressure that you record, it is going to be the data through measurement. And any data that you get through measurement, that's what we call quantitative data. So what then determines the kind of data that you're going to collect? Is it data through observation, qualitative data, or is it data through measurement, quantitative data? It depends on your study, the question of your study. For example, if the question of your study talks about effects of smoking, or what can I say? For example, if your data talks about trying to find out the number of people that are affected by malaria, in so area. Okay, that question obviously is pointing you to finding out how many in terms of numbers, in terms of quantity. So that is going to be quantitative data, and you're going to have to correct data through measurements. Okay, if you want to find out how many patients suffer from BP, how many, you are going to use that. But any other questions such as um, that deals with attitude, that deals with behavior of people, you know, that deals with practicing says of people, you observe, and that is qualitative data. We're going to see that in just a moment. Okay, so how do you get data by observation? You get data by observation through watching, sitting, using your eyes, and you watch what people are doing. Okay, when you watch people what they are doing, it's going to give you your data. You record that data. Okay, it depends on the questions that you've put in your questionnaire. If when you go to the hospital, for example, and you want to check um, how many people wash hands after leaving the toilet, how many do not, you just sit somewhere and watch what is happening. Okay, so that is what we call, that's how you gather data by observation. You just observe and record using a questionnaire or a checklist, and you do not use any instruments at all. Okay, you simply use questions that require you to answer yes or no. Okay, you can simply and now you can prepare your questionnaire. You can use multiple fixed categories. That is going to help you to come up with qualitative data or data through observation. For example, marital status: is it single, married, divorced, widowed? Type of housing, okay, is it formal house, compound house? As you can see, this is a checklist. So if it someone lives in a formal house, you don't have to ask them if they live in a formal house or compound house. They might not even know which type of house they live in. So it is up to you to observe and see, and then quantify or check that they live in a formal house. And except things such as marital status, you might need to ask, and then they'll be able to know if they are single or divorced. It can also be on ordinal categories. For example, satisfaction: very satisfied, dissatisfied, neutral, satisfied. Frequency of distribution: alcohol use, have they ever used, never, monthly, two to four times a month. All of that is type of these are some of the questions that you can use to come up with your qualitative data through observation. So once done, each observed value or response that you get, the response that you get, that's what we call value or data. Okay, the response that you get, that's what is going to be called data in this case. How do you get now data by measurement? Remember, there are two types of ways of collecting data. You can collect data through observation, you can, which we've talked about. You can also collect data through measurement. So how do you collect data through measurement? You are going to have to use a tool or an instrument that is available, or that is going to help you to come up with the data that you want. And then once you use that tool to measure, for example, blood pressure, you are going to have to, you do not have to write, for example, write blood pressure, and then at the end you just put, let's say, 120, and assuming that the person is going to know that because there's blood pressure here, you put 120. No, you have to put blood pressure like it has been put here. Then you put the instrument that is and then you put the unit, the number and the unit. Okay, for example, you are going to have to measure, maybe you have measured 3 patients, so you say patient 1 BP is 132 out of 80 per millimeter Hg, patient 3 such as that. Okay, you measure across different people, and then you have to give yourself a procedure. Are you just going to be measuring these people continuously, or are you going to measure the people maybe every after 5 minutes? Okay, so procedure. Okay, maybe you say every after 5 minutes you're going to reset and then start again, or every after 5 minutes I'm going to measure the left hand, then I'll go to the right arm. Okay, appropriate curve size, all of those. That's the procedure. Things that are going to help you to accurately measure what you want to measure. And then the other thing, of course, that you have to look at uh, is to make sure that what you, for example, uh, on part of procedure you can say calibrating. So I'm going to calibrate my thermometer, or I'm going to calibrate my scale, because maybe you know your scale, after checking it, it does not start from 0, maybe it's starting at 5. So you're going to calibrate your thermometer or your instrument, as it were. And then meaning once you've done that, you collect data like this. So this is the data that you need. Anything else is just helping you to accurately come up with this. So this that you've come up with, that is what you call a data. And then each of these points, each one, this one, it's called a data point. This one is also called a data point. And then the third one is also called a data point. Together, all of them in yellow as they have been put, they make what we call data set. So all of them, this together, this is what you call data set. Okay, that's your data set all together. Okay, so once you've come up with your data set like that, once you've come up with your data set, you can now you can now move on. Okay, uh, to what we are looking at as a data set. So in short, uh, collecting data through measurement, it is equal to using a rule to say I'm going to calibrate, I'm going to measure after 5 minutes, I'm going to maybe measure only females. Maybe, could be some questions like cervical cancer kind of questions that is or studies. You only have to measure females. Okay, and what instrument are you going to use? So all of this, then you turn it into the numbers based on what the instrument is going to give you. Then data set, this is a collection of all the data points, or all the values, okay, that you've collected from what you are measuring, or the characteristics that you're trying to find out, or from the variable. Okay, so here, why data set is important, because remember in biostatistics we're saying it's about understanding populations and relationships. So you are not going to deal with data points. That's why you have to measure. You can't measure one person and then conclude your study from one person. You have to measure people, different people of different age groups, different sexes, people from different places at different times. Okay, so that you come up with a data set, and data set is what you are going to now deal with. You don't deal with a data point, but a data set. And this data set, it is important because it will show you now how distributed the kind of variable that you are measuring is across the population, not just an individual. Okay, so it helps you to look at patterns across the whole population, as it were, so that when you make a decision, you make a decision that is going to help the population, and not individuals. Okay, and from there, now let's look at the different types of data sets. The different types of data. So data comes in different ways depending on how you've collected it. Remember, we said if you've collected data through observing, then that data is going to be called what? Qualitative data. But if you collected your data through measurements using instruments, that data is called what? Quantitative data. Okay, so why is this important for us to look at the different types of data? Because it is going to help us to know what statistical methods we are going to use, because there are just certain things that cannot be associated to qualitative data. For example, measuring the mean or measuring the standard deviation, you cannot use that when you are dealing with the qualitative data. Equally, you cannot use the mode, the frequency, when you are using what? Quantitative data. So it's important to understand what data you're dealing with, so that you can know what tools you are dealing with, you're going to use in terms of statistical methods. That's what we mean by tools. Okay, yeah, so let's start with qualitative data. This is the data that you get by data that you were observing through observation. And this kind of data, it is non-numerical. There are no numbers involved. Those numbers that are going to be involved are just going to give you a distribution of how distributed that variable is across the population, across different people, time and place. So data is qualitative data is data that is non-numerical, that gives you non-numerical information, uh, that helps you to describe categories or characteristics, okay, such as sex, marital status, that shows you the outcome. For example, was the patient cured, did they get better? Okay, as you can see, no numbers are involved here. If you are going to now, what numbers are used for when I'm looking at qualitative data, it is purely for distribution purposes. Therefore, for qualitative data, you do not compute the mean or standard deviation. You only describe the data using counts, actual counting, maybe 1, 2, 3, 4. For example, how many were females? Females were what? Were 10. So that 10 is a count. It has not. You have computed nothing, but only counted and recorded the count in its raw form. Okay, so if you count the number of people that are there, maybe 16 females, 8 males, then you know just by counting you haven't done anything to it. That is qualitative data. So, and if you the counts that you have, maybe you turn it into percentage. There are 24% of females in this study compared to males. That percentage is just showing you the distribution, how much of a percentage. It is easier to deal with percentages than to deal with numbers, okay, because if I turn it into a percentage, I can easily say the population in this country 20%. I can tell 20%, then you can calculate how many. But if I tell you to count the number of females across the country one by one, are you going to manage? You won't. But percentages, they are easy to deal with. And then when dealing with qualitative data, you also use the mode. That is going to show you how often something appears in a category. So there are three things here: counts, percentages, and mode. That's the kind of computation that you deal with when you are dealing with qualitative data, okay. Because you are just trying to see the quality, how distributed something is. So you do not use the mean, standard deviation, variance, correlation, all of those things. You leave them for quantitative data. How do you know that the data that you're dealing with is qualitative? You know it if you're talking about types. For example, um, types of um, colors, okay. In this population, 16 people like blue. So that, if you're dealing with types, okay, types of diseases, for example, types of all of the things that have to deal with types, it's qualitative data. Groups, okay, qualitative data. Male, female, okay, that's qualitative data, okay. So anything that does not have to deal with amounts, okay, it is qualitative data, okay. So yeah, let's go to quantitative data. Quantitative data is data that is numerical, that has numerical information which can be counted or measured. So quantitative data is data which is numerical information that is obtained by counting or measuring, okay. For example, age in years, weight in kg, systolic blood pressure in millimeter mercury, number of children in a household, okay. So if you've seen this, you can even be able to tell when we start looking at scales of measurement, which type of scale of measurement is going to deal with which type of data, either qualitative or quantitative. For example, if you look at nominal scales, nominal scales are the least in the category of scales of measurement, and they deal with categories. And which type of data deals with categories? It is qualitative data, as we've looked at it, okay. Yeah. But if you look at things such as ratios, that's quantitative data. So anyways, Quantitative data is data that is numerical. It has the information can be counted or measured. For example, we've said that. So whenever an instrument is involved to measure whatever you are measuring, that data that you are going to collect from using an instrument, it is called the quantitative data. I think that is the thing that can help you to actually know that this data is quantitative. You look at the data. Has this data been collected from measuring? If yes, from using an instrument. If yes, it is quantitative data. If that data has been collected without the use of an instrument, meaning maybe you were interviewing people or you were just observing people, that kind of data is what we call qualitative data. That is the divide right there. So how do you know that data is numerical? I think I've talked about this. Just look at, did you use an instrument to measure that data? If yes, then it is quantitative data. In other words, you can look at how much or how many, and this kind of data is going to actually, for tools, you are going to compute mean, standard deviation, variance, correlation, all of those things. You're going to compute them when you're dealing with quantitative data. Now, quantitative data is further classified into two types. There is the kind of data that you get, is the kind of quantitative data that you get where it gives you whole numbers. For example, if you ask someone to say, how many children do you have? They are going to tell you, maybe I have 0 children. So 0 becomes discrete data. You can ask them, so how many children? They will tell you maybe 7 children. 7 is discrete data. 8, 10, 16. What have you observed in that? It is that these numbers are whole numbers and there is no range in between them. They are not decimal numbers. It's not in a decimal, or it's not in fraction form. So such kind of data that you collect, it is quantitative data that is called discrete data. Discrete data. Think of discrete di as the same thing that would come from digital. Okay, digital and digital digit rather. Digit is a number, right? A whole number, like digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and those numbers, there's nothing like 7.9, 7.8. So it's a digit. Okay. So think of digit, discrete, as one thing. Okay, numbers that are used for counting starting from 0. And what we're saying here is that it is that this data, it is data that you use when you're looking at the number of maybe patients. You can't say I have recorded 16.8 patients. There is nothing like that. You can't say 7.5 children, 2.3 cases of malaria. No. So all of that. So discrete, whole numbers, no ranges. Then the data that you get now from scales such as weight, height, you can have 6.8, 6.9 to 67.3 kg. It has got points. Why? Because maybe between 7 and 9 there are numbers there in between. Wherever the scale falls, it can fall on 6.7. So that is what we call continuous. It's continuous data. Okay. Now, to give yourself a little bit of more detail of what right statistical methods are you going to use, or how are you going to interpret your results, you have to go beyond qualitative data and quantitative data, which we said qualitative data, this is non-numerical data that is used to describe categories, distributions. Quantitative data that is numerical, and it is used you obtain it through measurements. And there are two types of quantitative data, that is discrete data, whole numbers including 0, and continuous data that has got points, like 6.5 kg in terms of weight, or 9.8 in terms of height or blood pressure. Okay, so now what helps you to even get closer to knowing what statistical method you're going to use. It is the scales of measurement. Okay. So excuse me. Scales of measurement, we have there are actually four. With what we call nominal scale of measurement, we've got ordinal scale of measurement, interval scale, and ratio. Nominal, ordinal, interval, and ratio. So when you nominal scale, this is simply the lowest category, and these are categories. In this category, these categories are mutually exclusive with no inherent order or ranking. What do we mean by mutually exclusive and no inherent order or ranking? By mutually exclusive, we mean that there is only one data for one variable. Okay. For example, if you get male or female, you can only be male at this. You can only be male one at a time. You can only be female at a time. You can either have the disease or not have the disease. You can you can only have one status, marital status. It's either you are single, it's either you are taken, you are divorced, or there's nothing like it's a complicated relationship. So nominal scales, these are scales that deals with data that is categorical, or that are categories that are mutually exclusive, where you can only assign one value to in short, one variable can only take one value at a time. Okay, it's either you are divorced or you are not. Okay, so things such as marital status. So if you can see, at first we said we laid down different variables to say, for example, age, marital status. Now we want to look at all of that. Where do they fall? Okay, so in this case, marital status, age, what is this? Marital status, maybe HIV status, or status of your health status. Um, okay, all of these falls under nominal scales. And then there is no inherent order, meaning that the categories are just labels. There is no ranking. Being married and being single, it means they are on the same level. In this case, one does not have an advantage over the other. You being divorced and one being married, there is no difference. Why? Because given you haven't given values to these things. You're just laboring. Okay, you're just laboring. Okay, to know, for example, if you say divorce, how many are divorced? You do not know yet. So there is no inherent order by themselves. Okay, that's what we mean. So in short, nominal scales, these are scales that are mutually exclusive, where one variable is assigned one value at a time, and those values, there is no ranking between them or among them. Okay, one is not greater than the other. That's what we mean by no inherent order. Okay, so nominal scales they help you to organize data into meaningful groups. Okay, they're just used for grouping. Okay, allowing researchers to analyze the frequency or distribution of each category. Because if you said, for example, divorced, and then you look at how many are divorced, 16, how many are married, maybe 12, then you're going to realize that, oh, there are actually more people that are divorced than those that are married. Then you're going to ask yourself further to say, why are there more people who are divorced than there are who are married? Have you seen now? It is leading you towards finding out. That is what research is all about. And by you asking that question, what have you done? That is called a random variable. Then you're going to find out by starting to interview people. So obviously, this kind of research, it is falling under qualitative type of study, because there is no, you do not have to use the calculator to find out why someone is not married, do you? I don't know, but you do not have to do that. So just by observing, and then maybe you find out that most of the people, after you've questioned that question, that maybe the females are not respectful to their husbands, or their husbands do not provide for the family, so it forced the females to leave the homes, marital homes. or due to infidelity, it could be that, or it could be due to gender-based violence. You may find out that most of them left because they were mistreated, ill-treated in the marriage. So all of those things. Okay, so that's what research is all about. You probe further and further. That's why research is not the end of the question. A research does not answer the question. The research is it has to the research does not answer the question. Okay. Mwache, where Mwache? Okay. Anyways, so we were saying that the the meaningful the meaningful groups, it just helps you to put data into meaningful groups so that you, before you start assigning data into those categories. Now the the point here is that nominal scales just helps you to differentiate groups. Okay, to know that these are married, these are not, these have the disease, these do not have the disease. Okay, and these having the disease does not mean that they're disadvantaged than those who do not have the disease. When someone has the disease, it does not mean that they will die early compared to those who do not have the disease. What if the one who has the disease stays long enough, and then the one who does not have the disease gets bashed tomorrow? Anyway, that's not to encourage people to go about indulging, but what I'm trying to say is that these kind of data are mutually exclusive and there is no inherent order between them. Okay, so that said, I think we have to look at now examples. So examples such as sex, blood type. I've heard people talk about there's a certain type of blood type that exposes you to more malaria. Blood type A B, so you can have A B A B O. One who has blood group B is not advantageous to one who has blood group. These are just categories. Okay, these are just categories. There is nothing about them that makes them one to be greater than the other. HIV status, if you are positive, it does not mean that you are bigger or healthier than the one who is negative. We do not know yet. It's just categories. District of residence, those who stay in, for example, Kanyama, are not disadvantaged compared to those who stay in Kablonga, or who stay in Twin Palm, or who stay in Malaysia, in the UK. Okay, unless you probe further to find out their maybe conditions of living, how those conditions of living leads to their poor health. Is there evidence? Okay, and you remember, you can say, well, we've lived to see this happen, but research, you take every research as current. Okay, so nominal scales or nominal variables, these are types of variables. Remember, we're looking at types of data or variables. So nominal scales, so when you're looking at nominal scales, these are variables that are qualitative in nature, and therefore the only permitted measure of organizing data or helping you to evaluate data is the mode. That you use the mode when you are looking at when your data is nominal. Okay, you use mode. You analyze them. You look at the frequencies, the proportions, okay, chi-square tests, percentages, and then ordinal scales. Now let's go to ordinal scales. So ordinal scales add on to or add up to nominal scales. These are categories that have meaningful order or ranking. Now here, because people like comparing, ranking with above who. So here you go now. Ordinal scales. This is where you have meaningful order or ranking. But the differences between levels are not equal or precisely known. Okay, you know that maybe primary school is lower compared to secondary school, and you know that the tertiary school university level is higher compared to secondary school, but the distance of importance between primary level and secondary level, you do not know it. The difference, in short, the number of years that will take you to move from grade 1 to grade 8, secondary school starts at grade 8. From grade 1 to grade 8, how many years are there? 7, right? From grade 8 up to college, how many years are there? That's like 4 or 5, including the gap year. Or we can remove the gap year. We can just say from 1 to 8, that's 7 years. From 8 to 12, how many years? 4 years. So you can see that moving from primary to secondary, in terms of the gap, it is more compared to the gap of moving from secondary to university. But in actual sense, the ranking is that secondary school is higher than primary school. So here, you know, here, in short, here, this is where you put data in categories in such a way that it makes sense to society. For example, when you're looking at educational level, you can say you have to list them in this order when you are trying to collect your data, to say primary, secondary, tertiary. You can't start with secondary, then you move to primary, then tertiary, or tertiary, secondary, primary. It does not agree with what people know to be true in society. So in short, here, with ordinal data, you write your data in a way that shows an agreement with what society agrees to be true. For example, for pain, you have to collect your data in this form to say low to severe, or better, better versus worse, or worse better. Okay, less more. Okay, just like that. So it's, in short, this is just a different way of collecting your data in a way that agrees with society. But you do not know the exact distance between those values. Here you are permitted to use median, okay, mode, percentiles, interquartile ranges, and all of those things. Okay. But remember, for nominal, you only use the mode. But here you can use the mode, the median, there is no mean here for ordinal. Why? Because you do not have values yet. You do not know the distance. Now, let's look at so examples of ordinal. You have education level. In short, ordinal, from the word order. What's the order according to society? How society acknowledges that thing to be true. What is the order? So education, no schooling, primary, secondary, tertiary. That's how you collect your data. Stage of cancer, stage 1, 2, 3, 4, 4. Okay. Satisfaction with care, very satisfied, dissatisfied. Socio-economic status, low, middle, income. You can't start with middle, then you correct your data to income, to then you go to low to high. No, sir, no, madam, you can't do that. So we move to interval scales. Remember, we started with nominal scales. We moved to ordinal scales. We started with nominal scales, that are categories where there is mutual exclusivity. One variable takes one value at a time. You can only be female or male at a time. You can only have the disease or not have the disease. You can only be married or single. You cannot be married and single at the same time. But hey, today some people maybe are married in one aspect, in another they tell the person I'm not married. But anyways, realistically speaking, you cannot be married and unmarried at the same time. You cannot be single and be in a relationship at the same time, guys. So that's what it is under nominal scales. And those differences between objects or items does not have order. Being married is not better than not being married. That's what is there. Then for ordinal scales, ordinal from the word order, you simply order things according to how society knows it to be true. Education level, you start with no schooling, primary, secondary, tertiary, but you do not know, you can't say that the distance between primary and secondary is that moving from primary to secondary is easier compared to moving from secondary to tertiary, or moving from secondary to tertiary is harder compared to moving from primary to secondary. You can't say that. So there is no, you do not know the distance between those categories. And here on interval scales now, this is where you now put, you know, the exact order. So this is adding up to, this is exactly as ordinal scales, except here you know the range, the interval. That's why it's called interval. You know the differences between values. Okay, so these are numerical scales with ordered values and equal intervals between them. The interval between them is equal. For instance, 60 kg to 70 kg, 70 kg to 80 kg, 80 kg to 90. All the differences there is the same. It's 10 kg, 10 kg, 10 kg difference. Okay. Now here there is no true 0 point. Okay, there is no true 0 point. You know the order, you know the interval. These are scales of ordered values with equal intervals without a true 0. So what do we mean without a true 0? We know that interval scales, we know that these are scales that are ordered values with equal distances or equal values between them, or equal intervals, which in this case we've given an example of the weight 10 10 10 10 10 being the difference across all the weights, but they do not have a 0 point. No 0 point means that while you can measure the exact or equal differences between measurements, you cannot know how many times greater one value is compared to another, meaning that at 0 on that scale, the thing you are measuring is still present. Okay, but you have only simply decided to call that level 0. Okay, because you want to you want to know how distributed these things are. Okay, so to put it simply, a true 0 is an arbitrary 0, meaning that it is only chosen during questionnaires to show how high or how low from some point. Okay, so in short, you put your 0 as your definite point of movement, of distribution, so that if you collect, you show that, so that if someone say, you can say, when you're looking at a questionnaire, let's say from 0, you can pick from 0 to 10. Okay, meaning that if someone picks 5, you know that they're halfway. So anything close to 0, you can say that it is weak. Anything towards 10, it is what? Strong. So how satisfied? Very satisfied, it is towards 10. Less satisfied, it is towards 0. So 0 there acts as a point to show you how strong the response is. Okay, that's what a 0 there has to do with what we're saying. There is no 0 point. Okay, you're trying to show the severity, the perception of people. Okay, the attitude of people. If someone chooses 7 from a scale of, for example, 0 to 10, of which 0 is the least and 10 is the most, and you ask, how often do you study, and they put 8, you know that this person studies more. So these numbers are simply showing you how much or how often or how frequent. So 0 has no meaning in this case. It is just an arbitrary, it is a point that you put, or a mark that you put to say we want people to start moving from this place. You could have started even at 16. Okay, 16 could have even been called 0. 0 could have been 16. But for convenience sake, when these people are putting numbers, they put start with 0 to show convenience and smooth uh, showing of strength in terms of response, in terms of severity, perception, and attitude. So that's what it means when we say that these are scales that we call the um, the interval scales are scales of ordered values and equal intervals without true zeros, meaning that the zero has little or nothing. So equal intervals here means that the difference between two numbers represents the same amount of change, whereas the zero simply is an arbitrary point or a point that has been just put there to show uh, that that's where we start. Okay. Yeah. So such data under intervals, you can look at means, variance, standard deviation, and all of the other tests that you can conduct. Ratio scales. This is a scale that is a quantitative scale with ordered values, okay, equal intervals, and the true zero. So this one has everything. It's good. Ordered value, equal intervals, and true zero. So ratio scales are simply interval scales but with a true zero. Okay, zero here means complete absence of the variable. Okay, so zero here is not a mark. It has meaning. Means that zero is real. It is recognized to carry meaning. If you say 0 kg, it means there is no weight. If you say 0 children, there are no children. Okay, yeah. So um here, otherwise, it makes sense because let's say on intervals you ask a person, say 0 to 10, how often do you start? Can they seriously put 0? Eh? They can't. It's not adding up. Okay. All right. So yeah. But if you ask someone, say, how many children do you have, they can say 0. It makes sense. True 0. So yeah. So all descriptive statistics here are permitted, including ratios, proportions, means, and all of those things. So absolutely, examples of ratios: age, weight, height, area, number of phone calls received. In all of these, the zero means none at that of that thing. So zero has um, some meaning there. Okay, so that's about it. That's about it. I think we've done quite a lot. It's almost an hour, but yeah. Anyway, so I guess we're done. Yeah, that's what I prepared. Hopefully, you guys have understood one or two things. Yeah, so there we go.